Okay, so again, start here on the xy at the origin of the xy coordinate system. It then follows that after 4 seconds, the vector r of 4 seconds, this function notation, it's a vector function, is 68 meters times I minus 60 meters times j. We just found those numbers. 4 seconds, we go 68 meters in the x direction, we go negative 60 meters in the y direction, right? So this is where we are. We haven't yet addressed the path by which we got there, but that's where we are, okay? So after 4 seconds, you're at not very well, that's not quite the right angle with the x-axis, but it still represents what we have, okay? So here is r of 4 seconds. And let's say, you got 60 here, and you got 60 here. X is in meters, y is in meters, right? Now, of course, you started off in this direction, okay? Among other things, just because we calculated this at 4 seconds doesn't mean that you suddenly change direction and go this way, right? It's not what happens. When something starts in this direction at 20 meters per second, it keeps going in a very nearly that direction for at least a short time and gradually changes its path, right? Doesn't follow the path from here to here. It follows an arc, okay? And in general, if you have constant accelerations, even accelerations in both directions, you're going to always follow some kind of an arc, or actually if you have constant acceleration in both directions, you will end up tending to follow a straight line. But in this case, you're going to follow an arc. It's going to be a parabola. It's going to be a quadratic function, and it's easy to derive that. Okay, so anyhow, this is the r of 4 seconds, right? So there's a vector. Doesn't mean that this is your path. It means the vector with initial point on the origin and tail, well, where it goes according to this vector, tells you what the position is, right? And there's an advantage to this formalism. Not even a formalism, it's a vector function. Okay. So the r of t vector, how do you calculate the position after t seconds? Well, in the x direction, it's 17 meters per second times t, because you got constant velocity, right? In the y direction, it's wrong with that. If t is 4, I don't get what I should get, but we'll write this down. Okay, initial velocity plus 1/2 acceleration times t squared. Hey, Cole.
Hey.
Good to see you today. Okay? Make sense? So there's something wrong with that expression because it doesn't work out. I got to stop and think that through, get it right.